Welcome everyone to Future Forward, where we dissect the technologies shaping tomorrow's business landscape. Today, we're diving deep into something truly transformative, the rise of super agents. These aren't just chatbots. We're talking sophisticated AI systems capable of handling complex, diverse tasks. We have a fantastic panel of experts to unpack this. Let's jump right in.
Thanks for having us. It's a topic that's definitely top of mind for business leaders. The potential here is, well, staggering. Think about an assistant that doesn't just schedule meetings, but actively helps strategize, code prototypes, or manage financial analysis.
It is exciting, but the journey from concept to reliable, scaled deployment is paved with challenges. We're talking about moving beyond single-task AI to something far more integrated and intelligent.
Absolutely. Before we get into the solutions proposed in recent research, like this super agent system architecture, let's frame the problem. What are the big hurdles preventing these super agents from being everywhere already?
Scale and reliability are the twin giants we have to conquer. Look at existing popular AI services. They experience outages, sometimes for hours. They impose strict rate limits, especially on complex tasks like image generation. Now imagine depending on an agent for critical business operations or even daily tasks, and it just stops working.
And don't forget cost and latency. Running these massive large language models, the LLMs, in the cloud for every single request from potentially billions of users. The computational cost is astronomical, and the delay, the latency, can make real-time interaction feel clunky.
It's like trying to run a global Formula One team using a single mechanic working remotely via satellite link. Things are bound to get slow and occasionally break down spectacularly.
That's a vivid analogy, Expert 5. So the need is clear. We need a more robust, efficient, and scalable architecture. This brings us to the concept of a super agent system, as outlined in recent work. Expert 2, can you walk us through the core components of this proposed system?
Certainly, the architecture is designed to be modular and smart. It hinges on four key pillars. First, you have the intent router and planner. This is the system's front door. It figures out what the user actually wants.
And it's not just basic keyword matching, it needs to understand nuance. Get me coffee like yesterday implies memory and context. The paper suggests using techniques like function calling, which is more structured than just prompt engineering. It allows smaller, faster models to handle this routing reliably.
It's like an intelligent switchboard operator, routing calls not just based on the department name, but on the nature of the query itself.
Okay, so the intent router figures out the what. What happens next?
The request goes to one or more task agents. These are specialized agents. Think a coding agent, a finance agent, a research agent. They are equipped with the necessary tools like access to databases, APIs, calculators, and importantly, memory and retrieval-augmented generation, or RAG.
Right? RAG lets them pull in real-time, relevant information. Memory allows for personalized, context-aware interactions across sessions. So that coffee like yesterday request, the agent uses memory to know what you had, RAG or a tool to check availability and delivery times, and then executes the order. Tools like Langflow or AutoGen help orchestrate these workflows.
So specialized agents execute the tasks. What's the third component?
That would be the model router. This is crucial for efficiency. Not every task requires the most powerful, expensive AI model. Summarizing a short email is very different from solving a complex mathematical proof or generating intricate code.
Exactly, the model router dynamically selects the right model for the job. Simple task, use a smaller, faster, cheaper model. Complex reasoning needed, route it to the big guns, the state-of-the-art LLMs. This system might use accuracy-optimized routing for critical tasks or cost-optimized routing for everyday functions. It's about balancing performance and resource utilization.
A smart allocation of resources, and the final piece of the puzzle.
The fourth component ties it all together, especially for real-world deployment: hybrid edge cloud language models. This involves running smaller language models, SLMs, directly on the user's device, their phone, laptop, maybe even their car or robot.
This is where things get really interesting from an edge perspective. Running an SLM locally dramatically reduces latency. Tasks happen almost instantly. It enhances privacy because sensitive data doesn't always need to leave the device, and it reduces reliance on cloud connectivity and bandwidth consumption.
So the edge device handles what it can, quickly and privately.
Precisely. The system, often via an edge-based router, tries the local SLM first. If the task is too complex, then it intelligently routes it to the more powerful cloud-based LLMs. It's the best of both worlds.
From a business standpoint, this hybrid approach is incredibly appealing. Reduced cloud costs, better user experience due to lower latency, and enhanced data privacy, these are major selling points. It addresses key concerns that often slow down enterprise adoption of AI.
I agree with Expert 1, the hybrid model is key. But building on what Expert 2 outlined about the model router, that component's intelligence is paramount. Deciding when to go from edge to cloud or which cloud model to use, that's not trivial. It needs to understand task complexity, latency requirements, cost implications, even the current network conditions. Getting that router logic right is a significant ML challenge in itself.
And integrating all these pieces, the intent router, multiple task agents with their tools and memory, the model router, the edge cloud logic into a seamless workflow, that's a serious engineering lift. We've seen projects struggle with just one complex agent workflow. Coordinating several dynamically adds layers of complexity. Debugging becomes, quite the adventure.
It sounds incredibly powerful but also complex to implement. Expert 5, you mentioned debugging adventures. Any lighthearted war stories, or perhaps a moment where you thought, did we build this just to make our own lives harder?
Let's just say coordinating multiple asynchronous agent calls feels less like conducting an orchestra and more like herding cats, blindfolded during an earthquake. There was one time an agent got stuck in a loop trying to book a meeting room, constantly checking availability, finding it free, trying to book, failing because another agent just booked it, and starting over. We almost created the world's most persistent meeting scheduler.
Chuckles, I think we've all been there. It highlights the need for robust error handling, fallback mechanisms, and careful workflow design. You can't just stitch APIs together and hope for the best at this scale.
A cautionary tale. Let's pivot specifically to that edge component. Expert 4, beyond latency and privacy, what does running SLMs on device truly enable?
It fundamentally changes the user interaction model. Imagine appliances that understand complex voice commands instantly without needing the cloud. Robots performing intricate tasks locally, safely. Cars with truly intelligent co-pilots. It makes the AI feel integrated, part of the device itself, rather than a service you're calling out to. This requires advances not just in SLMs, but also in edge hardware. More powerful, efficient processors are key.
And the always-on capability is critical. If your internet connection drops, a cloud-dependent agent becomes useless. An edge-capable agent can continue performing many tasks, ensuring continuity. For businesses deploying agents in remote locations or in vehicles, that reliability is non-negotiable.
Okay, I hear all the enthusiasm for efficiency, edge processing, and sophisticated routing, and it is impressive engineering. But are we potentially optimizing ourselves into a corner?
Ooh, how so, Expert 6? Tell us more.
Everyone's laser-focused on making these systems faster, cheaper, more capable. But what if the real adoption bottleneck isn't performance, but trust and explainability? We're talking about agents making complex decisions, potentially managing finances, coding critical systems, even interacting with the physical world.
That's a very sharp point, Expert 6. Trust is the currency of business. If our super agent, no matter how efficient, makes one costly error due to an unforeseen interaction in its complex workflow, the reputational damage could be immense. We need guardrails, clear accountability, and perhaps simpler, more verifiable agent workflows for critical tasks, even if it sacrifices some efficiency.
I agree with the importance of trust. Technically, this ties back to things like better RAG techniques that provide citations for their information, model interpretability research, and perhaps even designing the routers and planners to favor simpler, more verifiable paths for sensitive tasks. It's not just about picking the best model, but maybe the most understandable one in certain contexts.
Building on Expert Six's point about trust, the user experience of interacting with these agents is also critical. If the agent constantly needs clarification or misunderstands intent despite the fancy router, users will abandon it. It needs to feel intelligent and reliable, not just be technically sophisticated under the hood. The interaction design is as important as the backend architecture.
That's a fantastic counterpoint and discussion. We need both the engine's power and the driver's trust in the vehicle. So, looking ahead, considering these challenges and opportunities, what are the next big steps? What should leaders be focusing on now?
Benchmarking is critical. We need standardized ways to measure the end-to-end performance of these complex systems, not just individual components. Identifying bottlenecks accurately is key for optimization. And continuous system optimization, developing smarter algorithms for routing, planning, and resource management is an ongoing research area.
Training the system components using real-world feedback is crucial. Reinforcement learning from human feedback, RLHF, or similar techniques could be used to fine-tune the routers, the planners, and even the task agents themselves based on how well they actually solve user problems and how satisfied users are.
Refining those task agents and workflows is essential, whether it's manual refinement by domain experts or using LLMs themselves to suggest improvements to agent plans. Making specialized agents truly excellent at their jobs will be a differentiator. Think of agents specifically tuned for medical research versus financial analysis. The required tools, data sources, and reasoning patterns are vastly different.
On the edge front, it's about co-designing SLMs and hardware. We need models that are not just small, but optimized for the specific computational capabilities and constraints of edge devices. And continued innovation in low-power, high-performance chips is vital.
Strategically, businesses need to start experimenting. Identify high-value use cases where agents could provide significant ROI, perhaps starting with internal processes to manage risk. They need to think about the data pipelines required to feed these agents, RAG, memory, and the integration points with existing systems. And crucially, heed Expert Six's warning, build trust and transparency from day one.
And let's not forget the societal implications. As these agents become more capable, questions around job displacement, data ownership, and potential misuse become more urgent. We need proactive discussion and regulation alongside technological development.
Fantastic insights from everyone. We've journeyed from the vision of super agents through the nuts and bolts of a system designed to make them viable, intent routers, task agents, model routers, the edge cloud dynamic, wrestled with implementation challenges and the critical importance of trust, and looked towards the future. It seems clear that while the technical hurdles are significant, the potential payoff is enormous, touching nearly every aspect of business and daily life. A huge thank you to our panel of experts for sharing their deep knowledge and diverse perspectives today. And thank you to our listeners for tuning into Future Forward. Until next time, keep thinking about how these advancements can shape your future. This paper introduces a design for a super agent system. The system aims to handle diverse user needs efficiently and cost-effectively. It understands user intent and routes requests to specialized agents or workflows. A key component is the intent router. It identifies the user's goal from their prompt. The router then sends the request to the correct task agent. This routing uses function calls for better structure and reliability. For complex tasks, an automated planner coordinates multiple agents. Task agents are specialized units that perform specific actions. They use tools, memory, and retrieval-augmented generation. Retrieval-augmented generation helps agents access relevant, up-to-date information. Another core part is the model router. It dynamically selects the best language model for each task. This choice balances task complexity, performance, and cost. The system can use large language models often found in the cloud. It also uses small language model that can run on devices like phones. An edge cloud router manages tasks between local devices and the cloud. It prioritizes using the local small language model for speed and privacy. Complex tasks are sent to more powerful cloud-based large language models. This hybrid approach optimizes latency, privacy, accuracy, and cost. The paper presents a blueprint for an on-device super agent enhanced by the cloud. Future work includes benchmarking the system and optimizing its components. Training the system with user feedback is also a future direction. The goal is seamless integration of super agents into everyday life.